going to be walking us through what a lot of these changes are and just kind of base level understanding, so we're all speaking the same language and we understand what the changes are. And then Tammy's going to do the second half. She's for field piece. She's a technical trainer with them of like, okay, so we know these things now. What do we do when we're in the field, and how does this show up kind of in the day-to-day? So again, thank you guys so much for coming. There's food in the back if you haven't got it, coffee over here, restrooms down the hall. That should probably be all logistical stuff. So Don, I'll turn it over to you.
I appreciate it. Thank you very much. I want to thank 2J Supply for having us out here too, and Jeff and Field Piece for teaming up with Chemours. So as he said, how many people have? What do you know when you get asked A2L refrigerants? What's the first thing that comes to mind? Anybody? Raise your hand. What's the first thing you're thinking about? What are you hearing? More money? Okay. Hey, on that note, hopefully after I get a little deeper, not too deep in my bio, I'm just the messenger, okay? All right, I'm just the messenger. All right. As he said, I'm actually from Coldwater. I've only been with Chemours about a year and a month maybe or so. I just came from Copeland. I was a senior technical trainer there. I'm more on the mechanical side. I've been in the industry 31 years, but 24 of those years I was in a truck. I still hold my journeyman license over in Fort Wayne. Like I said, I'm from Coldwater, so it was easier. Our oldest son is 39. He's actually going to be joining us for the training tomorrow in Indianapolis. He didn't know what he was going to do when he got out of high school, so I said, well, until you figure it out. He jumped in a truck with me, and now he's owned his own business for about 6 years or so. So I know a little bit about what you're doing. I've done quite a bit of stuff there, but enough about me. A little bit about our agenda today. I'm going to talk just briefly, maybe one slide on refrigerant history on how we got here. I try to stay away from marketing and sales, not that there's anything wrong with that. We're all salespeople. But then I'm going to talk about HFO. What the heck does that mean to me, you and I? Regulations a little bit. I have to touch on that only because I want you to understand how we got here. Again, I'm just the messenger. I don't get involved in politics at all. ASHRAE Standard 34 flammability testing. It's actually for toxicity and flammability, but that's where these numbers are coming from. They're the ones that classify whether it's flammable or non-flammable, okay? And then A2L safety and installation and service. And quite honestly, you might be really surprised if you're looking for a big wow factor, because, you know, not, in my opinion, not near as changes coming that we had from R22 to 410A. That's my personal opinion. I remember walking out of the shop the morning we took our little test for this new refrigerant that was going to change the world, Puron, and we all went out to our trucks to load up for our service call and said, I'm not putting that crap in my truck. You see those pressures? I remember it like it was yesterday. But so we're already there with the pressures. It's just going to be how to handle this a little differently than what we're used to. Resources, I'm going to touch on where you can find some stuff, not just with Chemours, but other places, AHRI, and ASHRAE and those different things. And then we're going to leave time for questions. My presentation is about an hour and a half maybe or so, and then I'll leave for questions. Depending on the engagement, I'm going to encourage you to ask questions, and ask questions right there on the spot, if you will. If we start to go off topic a little bit, I'm going to probably bring you back in though, okay? All right? So I have to do this. I feel I have to do this, and it's the only slide I have like this. But one of my challenges coming here is, who in the heck is Chemours? And a lot of people say it like CH, like Chewy. And it's chemistry that's ours is where the name derives. Now, that doesn't mean anything to you, but DuPont might mean something to you. So as of 2015, what was DuPont with refrigerant, trade names like Freon, is now Chemours product, okay? So that's step one. When you start to see the new product, hopefully you'll buy our product. From Freon, you'll start to see the logo Opteon, okay? That simply means it's the low GWP refrigerant. And I'll get into what GWP means to you and I and those kind of things. But that means that it's a low GWP refrigerant. It doesn't necessarily mean it's an A2L. It could be an A1, basically like R22 or 410A. In other words, not flammable, okay, or not mildly flammable, okay, for retrofit stuff. Because there's a lot of stuff out there, especially on the refrigeration side. And I taught a lot of that at Copeland, tore a lot of compressors down. I did more of the supermarket stuff, but I grew up in the field doing mainly HVAC. But there's a lot of stuff they're not going to be able to tear out on stores and stuff and go to CO2 on. Okay, so they're going to have gas for that to replace it. It just has to. Okay, and it's a lower GWP, but not as low as like they're requiring for new equipment. So it's kind of like a grace, if you will, an easier threshold to get something that's already existing, if you will, okay? All right, real quick, we had problems with, back in the 1930s, we had refrigerants like R12, CFCs. Now it had the highest of the ozone depletion, ODP, and the highest of the GWPs, global warming potential. Okay, at the time, the ODP is what's on the radar of science, all right? We know this, and we start to look at that. And we come out in 1950s, good old R22. Actually, just caught the tail end of R12. I haven't worked with R12 a lot, but a lot of my older friends have. Now I'm one of the older guys. HCFCs. Notice these C's, for those of you who aren't aware of that. That's chlorine. And chlorine's what was eating the ozone up. Now that's not just our industry. They're not picking on us. Okay, that's everybody's industry. My mom used to use Aquanet on her big beehive in the bathroom, trying to get her hair to go real high. It's everybody. They're not just picking on us. And the same thing goes for the HFCs too. There's a lot of HFCs out there. It's not just our refrigerant. So I just want to be aware of that. So still getting rid of that chlorine, lower ODPs, but still had high GWPs. So then we go to HFCs to get rid of the ozone problem back in the 90s. Okay, still had high GWPs. In fact, we went to 410A. We actually went up slightly on R22. But the real thing I want to talk about is, so these refrigerants that you see, these examples, are classified as A1. The letter is the toxicity. A stands for no toxicity or low toxicity, because quite honestly, I taught CO2 transcritical systems too. Anything with enough parts per million not ventilated will be toxic, right? We all kind of understand that. Okay, the numeral is your classification on the flammability. So 1 is no flame or low flame. No flame in this case. The higher the number, the more flammable it is. So like propane's like 3. Okay, so just to give you an idea. And I'm going to show you a couple slides on that. Moving forward, if you're not using industrial or natural refrigerants, you're going to be using HFO and HFO blends in a lot of places. Like our product is all the 454 series, the 454B, which is an Opteon product invented by Chemours. That is what most OEMs are going to go with, all but one. And I'll talk a little more about that later. Okay, when you see the 454Cs and the 454As, that'll be your medium and low temp. How many people do refrigeration in here? Is it all HVAC? You do both? Okay, very good. So that'll be your medium and low temps, and those GWPs are really low, like 150 compared to 4,000 on 404A. I know it doesn't mean anything to you yet, but I'm hoping that I can explain it well enough to where you understand it, okay? By the way, if you're ever taking a test, this capital letter means what? It's a blend, right? If it's a cap letter. Small letter means it's a single component like 134A. All right. The other thing that's fun fact is anything that's got the same number in it is the same components in the refrigerant. It's just a different ratio, different percentage. It could be 60-40, 50-50, 80-20. It's really about how low you want to go on your SST or your suction saturation temperature. That's what it's really telling you. This classification is ASHRAE Standard 34. Again, the first letter is the toxicity, and then we've got the new kid on the block, 2L, and I'll get really into that quite a bit. You might hear mildly flammable. You might hear low flame propagation. The L simply stands for the velocity. It's a little greater velocity as far as the burn going out, the speed at which it goes out. Anything under 10 centimeters per second is considered non-flammable or low flammability, all right? So what's an HFO? Now, I'm not a chemical engineer, but I work around a bunch of them, and I'm a product of a vocational school. That's how I started out in this industry. Actually, I started down the road at Wapakoneta. I was a laid-off factory worker. They moved our jobs overseas, and I jumped in a truck and started cleaning job sites and carrying someone else's tools. And that's how I got here today. But I'm going to explain this to you where I understand it. I like things, analogies and those kind of things. Okay, so an HFO is simply an HFC in disguise. Okay, it still has the carbon atom in there, okay? What they did was, what they found in the laboratories with people much smarter than myself, is they found that if they put 2 carbon atoms next to each other and double bond them, that when they get up in the atmosphere, they break up quicker. That's simply all it means. Because all refrigerants, with the exception of ammonia, has some type of GWP. Even CO2 has 1 GWP. So everything has some type of global warming potential. emissions that it's putting in the air. Again, it's not just our industry, but that's what an HFO is. By definition, the word olefin simply means two carbon atoms bonded together. That's so if you're ever on Jeopardy, throw me a bone out on that one, okay, if you get that right. All right. Now, let's look at this HFO molecule compared to what we have today. On the left-hand side, we have HFC 134A, okay? On the right-hand side, we have that same molecule I just showed you, 1234YF. The difference is what I really want to show you, the length of time in the atmosphere. 134A, 13 years. And these are approximate, but that's fairly close. And this is 10 days, okay? 10, 11 days, somewhere thereabouts, okay? Less than 4 GWP, that's a big deal with the EPA, and that's who's driving this. It's not anything to do with the government, believe me. And this is 1430. The higher the number, the more it's on the chopping block, okay? And the higher the number, in air conditioning, actually, we get a little benefit because it's smaller systems. So the way the EPA sees this is, if it's a smaller system with a smaller charge, they're going to allow a higher GWP. That's why you see so many people going to CO2 on 300, 400-foot line sets on rack systems, because more potential for leaks, bigger charges, and those kind of things. So the bigger the system, the less the GWP is going to be. You have a smaller window of opportunity. You might have to do multiple units with propane in it or something like that, or R290, all right? This is an old slide I was showing. I've been teaching A2Ls, by the way, since I came on board with Copeland. So it was an easy transition for me here because I was the new guy at Copeland, 6.5 years ago, and everybody was getting ready to retire. Believe it or not, I was the kid. And they said, you take that new refrigerant. We're going to be out here before it gets here. And you take the mobile apps, Copeland Mobile and all that, because we don't want to mess with that. You mess with that. So I got pretty good at it. But this was an old slide that used to say A2Ls are coming, and now A2Ls are here. But actually, they've been here for a long time. Does anyone know where you'd find A2Ls at right now today and have been able to find for the last 6 or 7 years? What's that? Mini splits, very good. The other answers are, mini splits is correct, by the way. The other answers are, if you bought a P-TEC unit or a window unit in the last 6 years, it's got R32 in it, I'd be willing to bet. And a dehumidifier, the same thing. And it might not be all of them, but the reason for that is a couple reasons. If you don't know, is this, for whatever it's worth category, R32 is owned by Daikin, okay? And a lot of the stuff you see up here, unfortunately, does not get made in America anymore. A lot of that's Asian driven. So it just went hand in hand, sort of, if you will, okay? That's why Daikin, while I'm on the topic, Daikin and anything they own, Goodman, whatever, they're going to go with R32 in their split systems and their, light commercial. Everybody else, some of them haven't announced yet, but everyone else is going to R454B in replacement of 410A. Okay, so you're already working around it, you just don't know it. Okay. Also, if you bought a car in the last 6 or 7 years, maybe even 8 years by now, okay, 9 out of every 10 cars made today have 1234YF in it, that molecule I was showing you earlier. It's A2L. It's mildly flammable or low flame propagation. Why was the auto industry so far out ahead of us? What do you think the auto industry was able to put it in an automobile so quick compared to like HVAC in somebody's home? What was it? Less volume's a great answer. Cheaper, very good. Well, we saw what the GWP was. It went from like 1,304. But the deal is automobiles have been working with much more higher flammable liquids than A2L refrigerants. That we've been putting gas in the back of our cars and we think nothing about it every day at a gas pump. We go out and click a switch with propane on a little igniter all the time in the back of our yard to cook out on the weekends or in the evenings. We think nothing about it. And it is apples to oranges, just so you know, okay? So they were used to putting that kind of fluid. Heck, you watch any kind of race car, NASCAR, whatever, Indy cars, they're fueling up and taking off at the same time, right? People would say we're crazy if we did anything close like that to HVAC, right? So it's around you. It's already around you. Just don't know it. Or you do know it, okay? But I just want to what I'm trying to do at the beginning here is remove the fear mongering, because everywhere I go, a lot of people think there's propane inside A2Ls, and it's just not true. Okay, so I want to establish that right away. ODP, GWP. You all remember your Montreal Protocol when we had to take our EPA card back when seemed like it was a lot harder. Now every wholesaler, or you can even do it at ESCO or whatever, you can get it. But I remember driving to Toledo at night to go take mine in the evening. It seems like 100 years ago. That had to do with chlorine. That was the ozone. Phasing it out, not phasing it down. The Kigali Amendment is an amendment off the Montreal Protocol. Now, Kigali is not a household name, but if you watch national news 2, 3, 4 years ago, 5 years ago, you might have heard the Paris Accord. Yes?
John, speaking of EPA card that you mentioned, there's going to be a new EPA regulation card that you have to get
Yeah.
for the new A2L.
Yeah, great question. So,
or is it something like if you already have your EPA that gets like grandfathered in?
As of right now, that's the way it is. What you said, the latter. So it'll be just like your 410A. It's not on the test, but so everyone that has an EPA card, you're grandfathered in. Okay. Moving forward, those kind of questions will be on your EPA test, just like 410A was after the fact. Okay. So, but great question. There's talk of possibly doing that, but quite honestly, I'm going to let you be the judge of it when the equipment starts coming out in the next 14 months. Some people are going to release equipment in the fourth quarter this year. I'm actually doing a big webinar with Ream in a few months, or a few weeks actually. We're going to do 2 in the middle of the week, but you'll start to see them all stagger some in beginning of the year, even though the AMAC doesn't enforce you to do it until January 2025 on the stop making the equipment. But so that's that. The Kigali Amendment is just an amendment off the Montreal Protocol. It's the small section that we referred to as the Paris Accord. Okay. It was an international law. We didn't sign it. They had to make an amendment off the Montreal Protocol because this only focused on ozone depletion. Didn't say anything about HFCs, all ozone depletion. So they found a loophole and said, well, we got to make an amendment on it. Okay. This is what the ozone looks like. This is an actual photo from NASA in 2008. Again, I don't get into politics. I'm just the messenger. Montreal Protocol, again, 1987. It was a phase out. This is an actual picture, like I said, from 2008. The feel-good story, as I've been telling everybody along the way, I travel somewhere in the high 30s, 40 weeks a year. This red-green dot right there is about the size of the ozone hole right now, if you don't know. Did anyone know that? It's about 99.9% closed. And they've already got a year that they're expecting it to close. It's like 2030 something or 2040. But yeah, they've already projected when it's going to close. So it's a pretty good feel-good story. And again, it's not just our industry. It's everything that we learned from chlorine, okay? You don't know what you don't know, basically. And if you watch humans all the way through life, until somebody gets hurt or something happens, you don't fix it. That's just our nature, and I'm being honest. So now we go into global warming potential. And so ODP, first of all, is, if you think of ODP, if you're on a test and you're if these two are on a test, remember, ozone depletion potential, it's simply the sunblock of the Earth, really is what it is. It blocks out the UV rays. That's all it does. So now we have GWP, and we have 3 different types of heat. What type of heat is the sun? I heard somebody say radiant. Did someone say radiant? Very good. It's radiant heat. How does radiant heat work? I remember on the scissors lift stop, all of a sudden the big change was we stopped taking down the tube heaters in the pole barns and everywhere else, and we started putting radiant heat in. And they liked them in factories and pole barns, and even people put them underneath their desk in the wintertime, because the way that radiant heat works is it doesn't heat vapor. It's very efficient. It heats that table, it heats your body, it heats my body. So when I'm up in an airplane or you're up in an airplane, when you put your hand on the window, it's still minus 65 out there, okay? Because it's not heating that vapor. It doesn't heat anything until it hits a mass. And by nature, it hits the earth and starts to warm us up. Some of it bounces off. The problem we're having right now is they've discovered quite a few years ago that this bubble around the earth, the atmosphere, greenhouse effect, okay, is getting a little thicker and thicker and thicker. So what's happening is I often say the analogy is the cars out in the parking lot today, it doesn't matter even if it's 75 degrees, 85 degrees, it's not even that hot. It's the same air inside the car that's outside the car. Sun's hitting the windshield, what's happening inside? It's getting hotter, isn't it? It wasn't until we crack that window we let that heat out. And that's basically what GWP is all about. All refrigerants have some type of GWP. The idea is just to get it down lower, okay? Like it or not, get it down lower so it disperses quicker. That's really what it amounts to. That's a very easy explanation the way I like to learn, but that's what they're doing, okay? And so again, it's a phase down, but in some years it's going to be a pretty aggressive phase down. You saw a 10% cut down last year in 2022, and you saw what happened to 410A. I'll just use that as an example. Prices went up on it. I'm not trying to scare you. I'm just letting you know I'm an educator. That's what I do. That's what I've always done. I just like to teach. Okay, I'm just letting you know on a very high level, like I like to learn, of why it's changing in there, so you hear it from the horse's mouth. Okay, the Manufacturing Innovation and Manufacturing Act, I'm going to refer to it as the AIM Act. Has anyone heard of the AIM Act? Yeah, quite a few hands going up. So the AIM Act is just for the United States. And ironically, the AIM Act mirrors or duplicates, runs parallel almost exactly with what was the Kigali Amendment on the international level, even though we didn't sign it. So if they did something we didn't like, we didn't want to sign it, okay? Now we've signed it, but the AIM Act is nothing more than on the international Kigali. It's only for the U.S. though, okay? It's only for the U.S. And what is the AIM Act? It's given the authority to the EPA to regulate a group of about 20 HFCs, okay? And they're HFCs. They're not just refrigerant HFCs. There's a lot of HFCs out there. I mean, everywhere. Everywhere we look, there's HFCs, okay? And I'll get more into that, what you're looking at. So the first step was in 2021. It was actually the AIM Act went into play on the 11th hour of the Trump administration, December 27th, okay? That's where it got. It got finalized and signed in September 23 of 2021. So what it said is the first step is allocations. Allocations, what does allocations mean to you? It means how much Chemours and our competitors can make. It's a cap, okay? At that very second of that very day when it was signed, or somewhere thereabouts, whatever you were making, that was baseline. That's 100%. And you start stepping down from that. And there's a roadmap, okay? And that's the way it is. That's why we didn't follow the Kigali Amendment, because it was slightly a little more aggressive, actually, okay? So this is the allocations. I'm going to show you on the next slide what that looks like for the future and what we're up against, okay? The second part of the AIM Act will be signed here shortly, at the end of this month or the first of next month. It's hard to believe that I'm saying that it's right around the corner because we've been talking about it so long. Sector controls simply mean that applications. It's not necessarily refrigerant, it's sectors. Is it chemicals, solvents, those kind of things? They're going to have like quantities and how much you can put in different applications, okay? So stay tuned, that's coming into effect real near. In the next 4 weeks, it'll all be finalized. And then the last but not least, I don't spend a lot of time on this only because it tends to muddy the water. And what I mean by that is the third step is the reclamation part of it. And it's also got to do with tracking QR codes and what have you. It's the U.S. Reclaim Program, and it's all about starting to reclaim refrigerant and kind of benefit you and us as an industry to reward people for recovering refrigerant and turning it back into people, wholesalers and what have you, okay? The reason I say I stay away from it, I don't deep dive into this right now, is because some of you might know it went into litigation. Hardy, several different organizations, ACA, all of them sued and said you can't do that. You're overstepping your boundaries, and the Supreme Court agreed with them. So it got shot down. So it's on hold, but more or less, I just taught last week at another big event, and Hudson was there, and they said the same thing, I believe. It's just a matter of time, it'll go back and play, but let's not worry about that now. It talks about reusable tanks and all kinds of stuff, all right? But that's what that part of it is, the reclamation on it. That's the third step. And it's a ways away, so don't worry about that right now. The allocations, here's what I want to talk about today. 2021 was baseline, all right? 2022, we stepped down 10%, all right, 10%. In 2024, literally around the corner, January 1st of 2024, we're stepping down another 30%. So by January 1st of 2024, we'll be making 40% less HFCs, all HFCs, in the United States than we were in 2021. okay? And you know what's going to happen there, right? That's an aggressive drop down so early. In fact, I'll take my Chemours hat off. I say it everywhere I go, or if I remember to say it. I honestly feel this, and if you don't find this to be true, email me, call me, and say, "Hey, fathead, you weren't right about this." I believe that the transition from R22 to 410A was a much easier for technicians. I truly believe that. The difference is because we had to understand TXVs better. We had to understand POE oil better. It was difficult times, and everybody stayed away from that equipment right away. Most people did. This is a shorter porch, if you will. That's the only difference here. It's a smaller timeline, a shorter runway to get where we're going. It's right here, right now, even though I've been talking about it for 6 years myself. As time went on, every year got further and further, you would get more people interested. But quite honestly, it's been out there for some time, the Kigali Amendment. So now this is the AIM Act. So in 2029, we're going to go down another 30%. The goal here is to be down to 15% by 2036. So it's not a phase out, but it's a, if you want to call it an aggressive phase down, it is. And there's different ways to look at it. In 15, 20 years from my experience, and I'm not very good at upselling things. I just never was. I treat everybody like they were my neighbor when I'm working for them. But the other thing is by 20 years on residential units, you're usually looking at newer equipment anyways, to be honest with you. That's my personal feeling. And by that time, who knows, maybe somebody will come up with a replacement for 410A. Honeywell has something, they just haven't unveiled it, but I don't know if they will. And I'll explain to you why. Okay, here are those sector controls I was talking about: refrigerants, foam blowing agents, propellants, fire suppression, specialty fluids. So Chemours as a whole, Jeff and I were talking the other day, we're a chemical company. We could be chemicals for paint, anything that's made from chemicals, silicone, whatever. But when it comes to the refrigerant side of it, it's Opteon. That's the people I work for. That's the refrigerant. So when I'm talking about these step down, it doesn't mean step down 30% of HFC refrigerants. It means 30%. You're going to have to pick your poison. And again, I like analogies, so I made this analogy. If you have a 5-gallon bucket and you can fill it up, the EPA says you can fill that bucket up however you want to, but they're all square blocks. And the bigger the square block, the higher the GWP. How many blocks do you want to put in your bucket? That's pretty much what it amounts to, okay? If you put a bunch of big blocks in there and sell stuff like 404A with GWP 4,000, you're going to use up your bucket pretty quick, okay? And that's the reason a lot of people are staying away possibly of doing a 410A replacement right now. They're concerned of not having what we're going to need down the road in the future. Right here is what that third step, I believe, is going to be a big part of it. The 2024, 2029, not to try to cause fear, but I believe from what I know that and I'm already seeing it everywhere I go. There's a lot of people that used to not take refrigerant, covered refrigerant. They're starting to do it. And they're starting to take it, because years ago, I was always taught once it's mixed with something, it's pretty much worthless. In fact, a lot of times you might have to pay them to take it. That's not the case anymore. And like I said, I just worked with Hudson last week, the head trainer with them. They'll take it, and whoever else. I shouldn't be just saying their name because I'm not affiliated with them, but check around and you'll see that refrigerant's worth something. It's worth something for sure. They guaranteed it's worth something. So make sure you know that. The reason I'm telling you that's important is not just for you, but your environment. And I think Tammy's going to get into recovery, right? Yeah, I'm going to stay away from that the rest of the way, okay? So that's pretty much what the step down looks like, or the phase down. Let's talk about this flammability thing. What's the big deal, Don? This is the flammability testing. It's done by a third party, okay? The American Society for Testing Materials. They test a lot of stuff, not just refrigerants and those kind of things. So it was done over here at a third party. Nothing to do with Chemours or our competitors. Nothing really to do with ASHRAE. They bring that information back to ASHRAE, and ASHRAE classifies it under a standard 34. That's how it works, okay? And here's what the classifications are: 1 through 3, okay? We've always had class 1. Examples would be R22, 410A, and anything else we've used in the past, okay? Not flammable, non-toxic, yada, yada, yada. And then we had a class 2. Okay, and that would be chemicals like 152A. You don't see a lot of that in refrigerants so much, but it's a chemical that's out there. But it is used in some refrigerants, but not as much as, it's not really a household name. But that was classified as a 2. It's flammable. And then we have number 3, And those class 3 would be refrigerants examples would be like propane or butane. Now that's highly flammable. I purposely missed this one because this is the new kid on the block, and that's why we're here today. This 2L classification has been around less than 8 years, less than 10. Let's just say less than 10 for the sake of not arguing. It's real new to the US. Asia and Europe have been ahead of us a little bit, like I said, with the R32 stuff. But this is really new. And it's so new, they had to make a new classification. There was no 2L up until not too long ago, okay? Because the flame was so mild or low flame propagation, they had to reclassify it. Again, that L stands for the low velocity of the actual refrigerant or the flame. So let's look at what this looks like. Again, increasing flammability, higher number. Going from left to right, toxicity. A is good, B is bad. Okay, a fun fact if you didn't know is ammonia has always been a B2. It's very toxic and it's flammable, okay? It's flammable. Well, when this new classification, this new kid on the block came out, this A2L, the ammonia people looked at that and said, well, if that's a 2L, then we're a B2L, and now they are a B2L because that classification was never there before. So that's changed recently. But Don, how do they test this stuff? So I was just in the labs. I think it's going on 4 weeks ago now. I went up to headquarters, what was DuPont, where they do a lot of testing, now Chemours, and I went up with the chemist and watched the chambers. I've been up there multiple times, but I'm always learning something, and actually saw these chambers where this takes place. I actually saw the V on the chambers, inside the chambers. You shut the door, you start doing whatever you want to do, and then you watch the computers and you ignite things. And this is how it works, okay? You close the door in the chamber, you're doing this flammability test for R34, or ASHRAE 34, pardon me. You put this rubber stop in this glass flask. You put just the right amount of air and the right amount of refrigerant. That's your LFL. You need a certain concentration of whatever you're working with to make a flame, okay, with the air. So they're trying to figure out how much refrigerant they need mixed with air to make it flammable or non-flammable, okay? Too much air, put it out. Too much refrigerant, we'll put it out, okay? So as soon as they get that right mix of that concentration, they're hitting these electrodes. And if it stays inside, if the flame burns and stays inside this V or this 90 degrees, it's classified as non-flammable, okay? Everybody with me on that? That's always been an A1 classification. And that testing has been around for years. And it gets way over my head why they use that 90. I asked, but when the chemical engineer started talking, I knew that was nothing I was ever going to need. But just know this is the standard for the testing, okay? This is what this looks like, gang. So same chart over here. I'm not going to beat that to death anymore. The higher we go up, the flammability. R410A, half of 410A is 50% of it's R32. The other 50% is R125, okay? It has 2,088 GWP, global warming potential, okay? All right? Now, when you try to replace that with something like R454B, we go down to the GWP of 466, and the EPA is really digging that because the maximum is 700 residential. So it blew the industry's mind, and when I was at Copeland, I quickly switched over that number and R32. We thought this was going to be the drivers, and that's exactly who it is. Okay, GWP is way under the 700. But what happened? We still have R32 in there. In fact, we bumped it up 68% from 50. Remember 1234YF, good old 1234YF? It's underneath the hood of your car. GWP is only 4. So look what was happening. R125, if you don't know, and I know mechanical stuff pretty good. Like I said, I've worked around compressors. I teach a lot of fundamentals. R32 by itself runs really hot on the discharge line. Does anybody know that? It runs really, really hot. So, and we always teach with compressors, you never want to be 225 degrees or above 6 inches out on the discharge line. The reason for that is on any compressor, the hottest point in the compressor, you lose somewhere about 50 to 75 degrees on average. So if you take 75 degrees being the worst scenario and add it to 225, you get 300. At 300 degrees, you start to lose your lubricity. At 320, you start to break down, and then you start to carbon up about 350. So it has nothing to do with brand of compressors. It has nothing to do with refrigerant. It has solely to do with oil. Lubrication, as you know, is key for compressors and the system, right? We have to lubricate. But look what happened. It's only in there for 2 reasons. It's a fire deterrent. You find R125 in fire extinguishers. We're a safe country. We're big, driven, OSHA. We want to be safe. That's the reason it was put in there with the R32, all right? Most other countries just went with R32 immediately. All right. But when you remove it, if you know, I'm not great at math, but you can see what's happening here. What, about 1,500, 1,600, somewhere thereabouts of the GWP was nothing more than keeping the discharge line cool and making it non-flammable. So all they did is remove the chemical that was the bad stuff, if you will, in the eyes of the EPA, and that's why we got a mildly flammable refrigerant. It's almost identical for capacity and everything like that, and I'm going to go over all that with you. So it's a balancing act, a seesaw, if you will, of getting that lower GWP. There's only so many molecules in the face of the earth is what they're telling me. There's only so many ways you can dice these atoms up. You know, you either want it flammable or you don't, or you want the GWP. So if you go with lower GWP, you have to go with what the science is capable of doing. All right. So again, lower 90 degrees classifies an A1. This is what this actually looks in the chamber I was talking about earlier. Okay, this is an actual photo. The digital camera goes off. They turn the lights off. They hit that electrode. They find that LFL, where it'll ignite. They hit the electrode, and that's what A1 looks like. Okay, if it's inside that V or that 90 degrees, we're good to go. It gets A1 classification. Here's what they saw when they lit up A2Ls. Now they're scratching their head because they've never seen anything flammable like this. It just barely broke that 90, but that's always been the template. It's always been the template, and there is science behind it, and I just don't understand it quite, to be honest with you. But it just barely broke it. So now they're scratching their head going, well, we don't really have a classification for that. Because an A2, it's close. It's not exact, but think of it as about somewhere around the 9 and 3 on the clock. That's where the A2 is. So when this happened, it was like, that's why they had to generate a completely new classification, because that's why you hear the term, as silly as it sounds, mildly flammable, okay? If the flame goes out a little bit, even a little bit from the line set or something like that, you bring it more air in, it puts itself out basically. And I'll show you all that here in a little bit, okay? So this is what propane and butane, I often say that's a more exciting day at the chamber in the labs, okay? But the point I'm trying to make is A3s or butane or propane are nothing like A2Ls. I don't know how many times when I ask someone, like, everywhere I go, what's your biggest fear? Is like, well, having propane in it. And there's nothing wrong with thinking that way because there's a lot of misconception out there, you know? You don't know what you don't know. I had to learn it too, right? Classes 1, non-flammable. Examples over there, 22 and 410A. 2L, lower flammability, 454B or R32. And then we have flammable, 152A. And then 3, high flammability, R290 on the refrigerant. And R290 gets really tricky if you don't. Does anyone work with R290 at all? Yeah. So R290 is propane. The difference is, and I've installed a lot of propane furnaces through the years living out in the country, right? The difference is it doesn't have any stench in it. It's because of the impurities, it has to be no stench in it. So that gets tricky for refrigeration guys when you go into a small mechanical room and you've got a leak, or Mrs. Jones or whoever calls from the building and says it's not working, and you walk in there and you hit a light switch. So you need a lot less propane or an A3 in the air to cause a flame than you do an A2L. That's really what it boils down to. You need a lot more refrigerant of the A2L, of that chemical, all right? One last shot at the A2L compared to an A3. I just want to make sure I drive that home, all right? There are no hydrocarbons in A2L refrigerants. Brian Orr asked me to do a presentation at his symposium beginning of this year, and I had to share a stage with 2 other people. I only had 15 minutes the night before I just made this slide. I thought, what's the point I want to get across right away with 300 people? And that's what I wrote. Okay, no hydrocarbons. Primary flammability perimeters. I just want to go through some acronyms. LFL, UFL, lower flame limit, upper flame limit. All right. Minimum ignition energy. How much does it take to light? Can it just be lit by going across the carpet and causing a spark by touching the doorknob? It can with propane. Or do you have to really put a torch up there or a striker trying to light it with 454B, and will it stay lit? That's really what it is. MIE, minimum ignition energy. It's really force. That's what MIE means. How much force does it hit with and strike, and what kind of spark? It's like 2 rocks or a matchstick, basically. That's what it amounts to. It's your ignition, all right? When we talk about burning velocity, it's the speed at which a flame propagates or front propagates, spread, okay, relative to the unburned gas. How far does it go out, and how fast does it go out, okay? Heat of combustion. Most everything has a heat of combustion. In fact, heat of combustion, this is the thing too I want you to understand to try to remove that. I know you guys aren't scared, but is anything with enough heat will combust, right? I mean, enough heat put to R22 will bust. It'll blow up if you have a warehouse full of it. So it's not like it's not combustible. I just want to be very clear about that. Now, I'm not really great at PowerPoints yet. I haven't been doing this all that long, but I wanted to put this in here just to give you a better visual. This is the lower flame limit. This is the upper flame limit. We're comparing our 454B, pardon me, to propane. I'm not trying to beat propane up. I'm really comparing A3s to A2Ls, okay, and letting you know the difference of it, okay? And in order for it to ignite, it has to be somewhere in this window. And you can see how much smaller this window is compared to that window, right? If it's in the blue, it won't even ignite. It's either too much air, too much refrigerant, or whatever. It's that window right there. So that's a lot smaller window to the opportunity for light. We need a lot less propane leak in this air, and it's just a little bit concentration will ignite it, all right? We need a lot more A2L. The sweet spot in both of these graphs is dead center. That's the perfect world for the ignition, okay? The further we start to get out, we start to add air. Same thing over here. The flame isn't as strong, okay? The sweet spot is dead center, all right? Just a real quick look. I'm not going to go through all these, but you can see the heat of combustion, minimum ignition. What I really want to look at, you can see how the A2Ls shine. That's why I feel we're going to A2Ls. It's going to have a big place in our industry moving forward. Get used to it, and you will be. Trust me, as soon as the equipment starts to show up, I believe after the first install, 2 installs, I believe that you're going to see, you're just going to get a manual out, the OEM manufacturer's instructions on an installation, and you're going to be good to go. I'm going to touch on a few things you're going to start to see, though. Not a few, a handful of stuff, okay? So what is the XL41? That's the lab name. I like to say 454B. And that's verse 410A. What does it look like? Well, on the PT chart, it looks almost exact, okay? Similar pressure temperature profiles, similar thermodynamic properties, almost identical, actually. Similar material compatibility. In other words, it plays well with others. It's not going to eat the windings up or eat the line setup. Similar oil types, it is the exact oil type. They're both POE 32. And similar system architects. What's going to be changing in the architects? Everything's going to be, say, it's rated for A2Ls, okay? I haven't heard a whole lot of stuff on the components of actually any material changing. And compressors, I was in those conversations right up until the last week. And there's nothing, some of the compressor technology, believe it or not, it's been around since it was made. There's not a lot that's ever changed with the scroll, basically. It's still the scroll, the same way it was. And you need air to start a fire anyways, right? So internally, it's not a big issue. Here's what I really want to point out to you. Just moving from 410A to 454B, just this one refrigerant by itself, we're reducing GWP by 78%. Just in air conditioning, moving from 454B, this is just one refrigerant, moving over to 454B. So that's why the EPA likes this stuff a lot. And quite honestly, there's nothing we can do about it. And I even tell my son this when he gets, they get panicky because you're trying to put fires out. I totally get it. Especially in the heat of the summer, you're trying to put fires out. You're not worried about this crap, and I totally get that, okay? But honestly, I've shoveled snow to get to my truck a lot in Ohio here, and we're a tough industry. We can do this. Trust me, we can do this. It's not going to be that big a deal. That's my personal opinion. So again, I'm not good at PowerPoint, so I just put this picture up here. I made this little red arrow. I just picked out somewhere on the low side. Obviously, this is the low side. This is your evaporator side. Right? Those are your temperatures, depending on what refrigerant you're using, along with your pressures. And this is your high side, okay? High side. By the way, if you're teaching someone out there, I'm just going to go off the path just a little bit here. Teach with your temperatures, not your pressures. Because if you get into different refrigerants, if you know what the temperature that walk-in cooler is supposed to be or the room's supposed to be, it doesn't matter if you flip refrigerants. I see the guy that does refrigeration nodding his head. Because you can put a lot of different refrigerants in the same compressor, right? But if you know the temperature, then you always know what you're doing. But I was taught backwards. I was taught pressures. On a day like this, 70 degrees, 70 pounds on the low side, and so forth. Okay. 117 on the PSIG on your evaporator. The evaporator temperature would be somewhere around 39.4 on 410A. 454B, it'd be somewhere around 44.2. And then I threw R32 in there to be fair about it, and it would be 37.A. So that would gives you a like for like of what it looks like, what the change will be in that area, okay? And I'm going to get more into detail here. Capacity, 410A is 156. Compared to 454B, it's 152. R32 is 171. Suction pressure, 130 on the 410 side. 454B is going to be about 120. 133 on the R32. Discharge pressure, 410A, 429. 454B, 390. So you can see the pressures are going to be a little lower. 430 on the R32. This is where it really shines pretty good. And 179 for 410A. And even though we took that R125 out of it, we're still right at 191 or somewhere around 190 somewhere. And then R32, like I said before, no fault of theirs. It just runs a little hotter. That 215 on the discharge line, okay? So that's what that looks like. Here's what this looks like. Everyone asks about glide. You know, yeah, but I hear it's got a lot of glide. 410A has 0.5 glide, less than half a degree. We don't even take it into consideration. We don't use dew point or bubble point or anything like that, like we do in refrigeration or anything else. 407C, if you're familiar with that, had a lot of glide. If you were doing your subcooling, you had to make sure you had grabbed the right one, the bubble point, right? R32 obviously is a single component, it's a 0, all right? Oil, POE 32, as I said earlier, 454B, same for 410A. The weight of the oil on the R32 will be 46. Higher viscosity, it runs a little warmer, as I said, okay? If you care to know the weight of it, only because somebody asked me the other day, it's heavier than like propane or you know, it drops low. So those sensors are usually 18 inches. So this is going to be a little heavier, okay? All right. What is glide? If you want to know glide, this is a single component, you know, or an azeotropic blend like 410A. So if this was boiling water, you know, and water has a refrigerant number, as you know, R718. We use it to transfer heat a lot, chillers and those kind of things. It's R718. If this was water, H2O, and we're boiling that, we boil at the same temperature or saturation point straight across until we hit vapor. That's considered the vapor side. It's superheat. That's also the dew point. This is the bubble point. This is your metering device. Now, when you get into glide by definition, or a blend by definition, I should say, is any two components or more. So if it has two refrigerants like 410A, that is a blend, like it or not, okay? Even if it's the same saturation point like 410A is, all right? So the way this works is, if you have like 4 components in there, or 5, the more you have, the more glide you typically have, okay? The most volatile or the highest pressure glide or refrigerant starts to boil off first. And it starts to boil off, and it continues like that with the least volatile or lowest pressure. The difference between this saturation point or boiling point and this saturation point between the dotted line is what they call glide. It's the temperature difference between the liquid and the vapor. That's really what it means to you and I, okay? The bubble point, we use the bubble point on the liquid side, bub, sub, and dew, su, okay? And on a PT chart, if you see bubble or dew point, you're working around refrigerants like that, you'll want to, these numbers could be all jacked up. Like on 407C, if you don't grab the right one, they're 12 degrees difference. You might think you're really high on superheat or vice versa, okay? POE oil, POE handling on it, it's going to be the same thing as we did before. Just be aware, there's nothing changing there. It's going to get back to a lot of basics and fundamentals that we should have been done. What you're going to see later on is a lot of stuff that was good practice before is going to be required now, and I'll show you how they're going to require it, okay? POE oil, as you may or may not know, in its organic form, part of the process is removing moisture from it, okay? That's why you can't keep a line set open for 5 minutes or longer. It wants to go back to its natural state. It's very, very hydroscopic is what they call it. Big fancy word, hydroscopic. And that moisture goes back to it. In fact, when POE oil first came out, if you don't know, this came out in a plastic jug. It lasted less than 6 months. And they started seeing compressors fall apart. It actually was leaching the moisture through the plastic. So that's why you buy POE oil in a tin can today with the seal in it, okay? A2L refrigerant service and installation. What's not changing? PPE. For the most part, everything's going to stay the same. There's really not a lot of difference in that area at all, okay? And when it comes to the work zone, you're not going to have a certain work zone, 6 foot, 10 foot, or whatever, that you're not going to be able to bring things into. Like a cordless drill will not ignite this refrigerant, all right? And there was talk of having the recovery machines outside that work zone. There was originally talk of maybe 6-foot work area, roped off, coned off, whatever. That's just not the case. The only time you'll want to keep the equipment, if you work with really large chillers, okay, they have a larger recovery machine. That'll need to be 20 foot out, okay? That's the ASHRAE law. UL, if you don't know, UL, when you see UL, that's how the equipment's tested for its safety. ASHRAE is simply how the equipment's installed, okay? That's what it amounts to. UL, the equipment safety. ASHRAE is how it's installed. That's what they do. How do you install it when it gets out in the field? All right. Refrigerant cycle is going to be same. I know this sounds silly, but you get those questions all the time. Well, is anything changing here? Again, these components are going to be rated for A2L and have been for quite some time now. Any tools moving forward, as Tammy will tell you, we want A2L equipment to be bought. And I'm going to stay off that right now, but I will say one thing. Don't think that new recovery machine you bought last year or 2 years ago necessarily is obsolete. That's not the case, okay? They tested a lot of the old stuff. They're just putting rated on it now. And I'm not telling a top secret. They're being very honest about it. Go to their website. If you see your model number, it says it's A2L rated, you're in good hands, okay? And you might be pleasantly surprised from what I'm hearing, okay? As far as charging, it's going to be the same as we did before. I'm not going to go through each one of these because I know you've got a lot of experience in the room, okay? After the charge. Always when you do this charge, so that density number I showed you earlier, you're going to need to know that. Typically, from my experience, tell me if I'm wrong, 15 foot of charge typically in the unit, and that goes for not only 15 foot of the line set, but also the evaporator. That includes that if you didn't know that. And then you have to do your math, right? For years, R22 was 1.08, for the foot by the density, the weight of it, okay, multiplier. And you saw the density earlier on 454B. So you'll have to do your math. And then before you start the unit, as always, you'll top it off as a blend, even though I told you, that this blend and blend. And we talked about glide. I want to talk about a little bit about fractionalization too, because that's been brought up to me quick. There's not, I don't want to leave as enemies here. I'm just telling you what I know. And I learned this a long time ago by sitting and training myself from Honeywell and different ones is there was a lot more emphasis on fractionalization than needed to be back in the day, okay? And I've talked to everybody. In fact, the person I'm getting ready to work with at Ream actually was at Carrier at the time, and he helped write that book. And what the book said basically is, if you lose refrigerant on the suction side or the liquid side, you need to pull the charge and start back over. Nowhere in the pamphlet does it say you can't use the refrigerant you just recovered from that system. And what he told me was, since we've been working together the last few months, is, Don, at the time, we didn't know. We were new to POE oil. We were new to the charge. We weren't sure what was going to do. And if you've ever been on a tech support call, like I know you have, it's happened to me a zillion times, especially on mini splits or geothermal, which I did a lot of. You're on there. If you don't know where you're at, what do they tell you to do? Pull the charge and weigh it back in. That's just the way it is. So that was their thinking. It was new to them, and you don't know what you don't know. So they put that in there to really cover themselves, basically, to make sure we were all starting fresh and we had the right charge. Okay. In fact, fractionalization, if you don't know this, happens every time a system shuts down if there's a blended refrigerant. Fractionalization happens every time. And it happens in the coils where there's liquid and vapor and saturated refrigerant. But it happens naturally every time a system shuts down if it's a blended refrigerant, especially on your 400 series. Okay. So there's the planets have to line up almost perfectly for anything to happen. It really has to be a slow leaker, and it keeps leaking for 5 or 10 years and you don't fix it. Okay, then it's possible. Okay. All right. Do not slug the compressor. What I mean by that is when you get the system running, even though I spent the part of the day saying the vapor pump, the compressor's a vapor pump, okay, we're going to top off on the suction side. I like this metering device or any type of metering device similar to that. If you don't know about them, you put them on the tank. Basically, it's like a piston, if you will, or a fixed orifice. The thing that's cool about it is, unlike our calibrated wrist, when we throttle it and then shut it off and wait for it to stabilize 15 minutes later, okay, this trickles it in very, very slowly, and you can nail it right on a dime. There's no overshooting and then, oh, shoot, I got to take charge out. It's really, really cool. But I'm not promoting this product. It's anybody's product out there. I just like them. That really stems from my Copeland days, honestly. But if you don't do that and you put too much charge in that refrigerant or that compressor, you take the chance of slugging it. Airflow, airflow, airflow. You have to make sure airflow is right, just like we always have in the evaporator. And I know this is all fundamental stuff for you guys, but I don't know how many times I've been on calls or helped people and the airflow wasn't right and they were working on their own problem, or it was showing them overcharged and it wasn't. You know, a fan blade, anything condenser, universal motors, if the blade's put down too deep, we'll throw it off, right? Subcooling, superheat, and did I mention airflow? Airflow is a big one, has to be right. All right, service vehicles, under the materials of trade, it's business as usual, the MOT. What I mean by that is it's the same restrictions that we have now in place. 440 pounds, regardless of the hazard. In other words, included in that 440 pounds in your truck is going to be your acetylene and all that stuff. So nothing's changed, all right, in that area. Federally, there are no placards required on your service vehicles. Now, for transportation, there's going to be box trucks, semis, that's a different story, okay? But that's somewhat normal, okay? So not a big wow factor there at you, all right? What is changing? Again, A2L refrigerants. I know this sounds silly that I got this on a slide, but after I showed you what the PT, the pressure temperatures look like, inevitably, someone's going to do this, okay? Here's the problem is you're going to see on the new equipment, they all have safety devices on them, okay? And even though I spent most of the morning telling you that it's mildly flammable, there's nothing to worry about, there's a reason. It's all about liability, okay? And I'm going to show you what we're doing with the tanks and our competitors are doing with the tanks, and the OEMs are going to show you what they're doing with their safety features, and it's got to be in there, okay? Because the right concentration, it is possible, okay? It is possible. So don't put the new A2L refrigerants in A1 stuff that's existing out there, all right? You're going to start to see mitigation strategies. I'm going to focus on M2 because that's going to be the residential world, like commercial. M2 simply means that's kind of at the bottom of the barrel. There's an M3, M1, a system without mitigation at all, okay? M2 will be, you might just see a sensor. That's what you're going to see in most split systems. You know, that's what you're going to see. And depending on the OEM, and I'll let them speak for themselves, but we've worked with all of them for the last year, training them on the refrigerant so they can put it in their dealer's books to train them for their education, like you guys are doing here, okay? So some OEMs are going with a separate board. The sensor is on the coil, clipped on there, and that wire goes right into that second board, which has a Molex plug that goes into the main board. The way the sensor works is once it senses over 20% of concentration in the air, the fan comes on. So it's just backwards of like smoke detectors and those kind of things. I've done a lot of commercial jobs where they shut it down, the strobe lights go off. This is going to be just the opposite. They want to bring more air into that to lessen the concentration to make sure it wasn't a nuisance call. Once it gets lower than 20%, it comes back on and starts to run again. That makes sense? That's basically what that's very high level, but each OEM will be slightly different, but most of them are going to be, they're almost going with the same ideas. Now, where that's going to change at is if that furnace goes from an upflow to a horizontal or whatever, you will have to, remember that weight I told you about on the refrigerant? You may have to relocate that clip on the other side of the coil. If it's an air handler, it's going to be on one side. If it's a furnace, on the other side. It depends which way the air is flowing, basically, okay? But that's what, on larger systems, not that what we're going to do here in residential or light commercial so much, maybe in light commercial is you're going to start to see possibly solenoid valves, pardon me. And if you're familiar with a pump down type operation, when the alarm goes off, the sensor goes off, this will pump the refrigerant outside to the condenser outside the area. And it really depends on what type of building you have there. And the size of the charge has to be taken into consideration. What's the building being used for? That's how the mitigation strategies. You'll bring in fresh air as we show here. You might even have, you're going to have sensors inside the unit. Yeah.
Why is mitigation so important?
I know. Here's my personal opinion. Great question, by the way. It goes back to that, what I was comparing the car with on the fluids. I don't want to try to be funny or sarcastic, but you would probably have a hard time selling cars today if you said we're going to use gas in them. I'm just being honest. So it's all about liability. It's just the world we live in now. And when I show you what we're doing different on the tanks, just the tanks alone, it's all about light. Some of it's required, but some of it's our own choice. And our competitors chose the same way. We agreed on it, okay? It's all about making sure when it leaves our hand, this is safety. It goes to the OEM, they're making sure it's safety because they're liable. If something does, God forbid, happen, okay, when it gets to you, then you're liable. Okay, you have to follow that manual and follow that ASHRAE installation goes. So that's basically what it is, because it is possible with the right concentration, with no ventilation, it's a higher flame than it was A1. So, and you don't know what you don't know, quite honestly. So, yes, that's correct. Yeah, yeah. Yeah. So as you know, as we talked about before, R290 is like 1.52. So when I've done houses up where I live at, this, I know from being from Ohio, sometimes I have to explain it. We run our own gas lines up to the building, right? Then the utility company comes and ties them in. That's what I did at my house 34 years ago. We were on fuel oil. So you trench it out there. So by code, when you put a propane meter in like that, or a regulator, you have to worry about the window 3 foot diagonally from that, because it drops. On natural gas, by code, you watch the window above it and then put the bar there before they put the meter on. That's the way it works. And the refrigerants, this comes into play the same way. CO2 in a vapor is dry ice, right? And they put dry ice in warm water for rock concerts. It stays real low to the stage. That's CO2 as a vapor, dry ice. The same thing at Halloween. That's what the vapor looks like. That's the weight of it. So this is actually even heavier. So if you can visualize that Halloween bowl, it's even heavier than that, okay? So something to think about there. But it's all about safety and making sure. Believe me, the OEMs aren't happy. I can tell you that right now. They would rather not be doing this. But again, it's ASHRAE, and you're being forced to do it. They're being forced to do it, okay? Same thing, evaluate the work area, okay? A lot of common sense here, safety hazards. Here's the one I really want to point out. You're still going to always have a Class B dry powder fire extinguisher on there. Like I said, okay, a lot of this is getting back to the basics, what should have been good practices already. Ensure the work area is well ventilated. If you're in a confined space, avoid to accumulate a flammable refrigerant. You might need to bring ventilation in yourself. This is for larger chargers, I feel. Label match the components to the refrigerant. All components should be designed for A2L. So what that's saying is anything you replace on an A2L system, it should say that it's rated for A2L, or vice versa, okay? A2L can go into A1, but it can't be vice versa. Check the manufacturer's literatures. They are working aggressively right now on this. Like I said, the AMAC says we can't make 410A equipment January 1st, 2025, that day. But what you're seeing right now is everybody's going to start to release their equipment gradually. Some are going to release in the fourth quarter this year. Some are going to release in the first, second, third, fourth. It's going to be gradually, 10%, 30%, 40%. They can't wait until the final hour and just say, oh, and they're backlogged with all this 454B. So you're going to see those 2 assembly lines running just like R22 was with 410A, basically, okay? So if you have big projects, like I did a lot of multi-housing over in Fort Wayne where I'm licensed at, you want to make sure you got that equipment already logged in and stuff like that, or you're going to have 2 different refrigerants on that job site. And I mean, we would always do units, 300 units wasn't unheard of on apartment complexes, okay? After the initial installation, this is the biggest one, place a permanent label on the equipment with the contractor, technician, the contact information, date of installation. It also talks about the pressures and then the evacuation and all that stuff. And basically what's going to happen here, I wish this wasn't cut off. What's going to happen here is, I've seen it both ways. A lot of the OEMs are going to put these decals inside the door of the outside unit. You're going to need to document this on startup. It's basically a startup sheet. So if something goes awry, God forbid, if something goes awry and something tragically does happen and a fire marshal comes in, they're going to be looking for that if it looks suspicious of where that refrigerant line was. I'm just being honest with you. It's going to be about documenting that, okay? Some are just going to come in a packet and then put it on the door, but it has to be there, okay? It has to be there. If you're under codes like I am, I couldn't put an A coil in without, if I didn't pull a permit, we were busted. And $500 was the lease fine, so you didn't pull. They go around in Fort Wayne and Allen County. It's very strict. It's under the international code, and they look for vans with logos on the side of them. And if they look in their computer that no permit was pulled there, you're done, okay? Just being honest with you, all right? Tools. This has gradually got a little bit bigger, okay? As I was telling Tammy and the others from Field Piece, every time I would go somewhere else, someone would come up. and tell me, hey, we sell tools for A2L. So I've tried to, I have no dog in this fight. I'm not affiliated with any of them. I just just letting you know the tools are out there. It doesn't necessarily need you go out and buy all these tools. Compound gauges, if the refrigerant's not on there, obviously you're going to need new ones. The hoses are pretty much the same, but they're going to say A2L rated, all right? Okay, but I personally would buy new hoses. That's just me, all right? On digital stuff, Bluetooth and stuff like that, your apps will update. You'll have the refrigerant all there, so you're good there on that kind of thing, all right? Check with the manufacturer's website. As I just said, right-hand threads on the manifold hoses. Tammy's going to bring something up here a little bit that she's going to talk about based on service ports, and then recovery cylinders. These are going to have a red label on them, like the refrigerant tanks are. I'm going to talk about that here in a little bit. Vacuum pumps, again, check with the manufacturer. The big fear on vacuum pumps is always, it's the switch. It's any kind of MIE, that ignition source. Plugging in a cord, the switch, okay? Recovery machines compatible. Electronic leak detectors compatible. If you think about the detector, somebody asked me this yesterday. Yesterday morning, I was doing a podcast for podcast up in Canada, and he asked me about that. And I said, you know what? That's a great question. I don't know what the sensors. I'll have to ask Tammy what they're doing with their sensors if it's upgrading. But my thought process was this: a lot of the blends that we're making now, let's say 454B, for example, the refrigerant's already out there. It has R32 in it, 1234YF, that's in the cars. So that's already been sensed on sensors. It should technically pick that up already because it's in there, right? So just a thought, just my thought on it anyways, okay? Hand tools are going to stay the same. We're going to be going from colors to off gray, off white, however you want to word it, okay? The reason behind this is when A2Ls were being thought of, how do we distinguish these tanks? They didn't want to make a slightly off green tank from 407A or whatever and have it sitting next to each other and have it, someone starting out new in the industry grab the wrong one and something bad happen. So moving forward, anything that's not an A2L, so what was green and blue and or brown and orange are now going to be just off gray. They're going to be stamped just like they always were on the side with the refrigerant that's in them. All A2L refrigerants will have a red band around them, okay? So the colors are going away. I think about a year ago, somebody shot me a picture and said, is this counterfeit? And it was one of the new tanks that just came out. It was kind of ironic. So what's changing on our side, on the tanks, okay? First of all, the red band. That's going to be a flag. A2L refrigerants are in that. Can't put it in A1. The DACs will have a left-handed thread on it. You'll need an adapter. It's not about selling tools. These adapters were just manufactured. They're very, very new. Believe me, I was every day for about 6 months ago, I think it was, 7 months ago. Do we have any information? And we have people actually helping with the design on these tanks, and I can't release anything. They didn't want it to go public. So this stuff, at the time, you couldn't even find someone with this left-hand adapter. I mean, there was something over in Europe. We all did a lot of searching, okay? But you'll need this left-hand adapter. Now stay with me. At first I thought this was ridiculous myself, but having family and friends in the field and all of you, it made sense one day. Everywhere is like here, okay? And what I mean by that is there is a employee labor shortage everywhere, all right? Everywhere, and it's major, right? And it keeps getting worse with retirees. So people are getting put in positions that they're probably not ready for. On a 90, 100-degree day, depending on where you're at, Arizona, whatever, Tim might be being asked to go in to run service calls. There's so many calls behind, okay? The thought process is if Tim goes out or Tina goes out and they grab the wrong tank and they go to throw their hoses on it, it doesn't go in the threads, hey, I know this is going to sound stupid, but I'm fairly new. I can't get it on there. The hope is that someone, whether it's the counter at the wholesaler or the service manager, says, stop right there. Does it have a red band on it? Again, it's all about liability. They're not trying to sell more tools. They really aren't. They were just trying the best way, safety net, to keep anybody from getting hurt. Simply what it is. What's that?
Dummy.
Yeah, yes, exactly. So you will need this adapter, just so you know, on the A2Ls. The next one's going to be shrink wrap, not a big deal to you or I. Simply the thinking behind that is they don't want any bad actors coming from anywhere else outside the U.S., if you will. The reason for that isn't so much their quality of the refrigerant. That's what we think, or refrigerant manufacturers here think. But the other one is, in my thought process, is a lot of times it's not even the chemicals that are on the tank that they say they are. So if there's R125 watered down, for lack of better terms, I guess, in there, and they find it all the time, by the way, you know, that's high GWP, and the EPA, AMAC, doesn't want that. So that's the reasoning for this. They know it's been tested, all right? Next slide will show you on the safety features. This is a safety tank, or a A1 tank as of today, okay? It's a pressure disc. I'm sure you all know this, but the way a pressure disc works is, let's say it gets 130 degrees or above, it blows the whole charge. Now in Ohio, I've never had it happen to me, but if you're in Arizona or Southern Alabama, they'll tell you it's happened more than once in their lifetime. I've had people in Southern Florida tell me they came out on the driveway 2 hours later and the tank was spinning in the driveway because they left it out in the sun. So it's there for a reason, okay? But the way it works is, the main thing is, and it's not set in stone on 130 degrees. It's based on pressure, because every refrigerant's going to have a different pressure temperature, right? But that pops. So when we decommission it, when it's empty, we're supposed to puncture this or remove it, right? So somebody doesn't come and pull it out of the dumpster and blow their knee off at night and put air in it, right? Moving forward on the A2L tanks, you're going to have a relief valve. And the way the relief valves work is, instead of blowing the whole charge, it's going to blow just enough charge, even though I spent the whole morning saying it's not as bad as it seems to be. It's going to blow just enough charge to take it out of the pressure that they feel is somewhat dangerous to blow the whole charge and shut it down, okay? This is much more rigid than that pressure disc is, more like a propane tank. You're going to be required to puncture a hole in the side of it with a non-sparking device, brass tool. I'm sure you'll see a bunch of them coming out in the near future. You're going to be required to circle that hole that this tank has been decommissioned, and then write empty on it. That is good practice. Okay, that's what the good practice moving forward is on A2Ls. But more importantly, I just want you to know how the relief valve is going to work, okay? Back to the basics on a lot of this stuff. Some of this stuff, I shake my head because I really didn't work around a lot of people that, or any people that did some of this stuff. I wasn't even aware of it, but safely remove refrigerant following local and national codes, that's a no-brainer, required. Purge circuits, best practices. Now, we don't always do that, and I'm guilty of it too. But it was best practice. So what they're saying is, they're not talking about using nitrogen to remove oxidation while you're brazing. That's not what they're talking about. They're talking about when you cut a line open, okay, you're supposed to run nitrogen through it ever so slightly to remove any residual refrigerant in there. It's going to be required with A2Ls. Evacuate the circuits. That's always been practice. I don't know anyone that does it. I mean, I bought my first vacuum pump literally in the first month payroll deduction down in Lima, Ohio. And it's going to be required now. You're going to document all that, okay? All this is required. Leak pressure test. This is going to be the big one. This is going to be the big one, especially for retrofits. If you're not under a code and the building department says, that was installed 25 years ago, and we have record on that, and at the time you pulled a permit, it shows you would have done it by code. I've been using striker plates for years. Does anyone ever use striker plates? So basically you're putting a plate up there. They got spikes on the back of them. If you're doing residential new construction, you spike them right on the wood there, the width of the 2x4, inch and a half, okay, and they stop. So if you have a refrigerant line or a plumbing line, anything to do with water, plastic, whatever, it doesn't allow you to nail through the drywall in that area. That's basically what it means, okay? So you're going to have to prove, if you're not under any codes, you're going to have to pressure test the line set, okay? And you're going to have to document that, all right, to prove that it was done, whether you're under any codes or not. You're going to be required to document that on the new equipment. You can basically, what I'm saying is, you'll be able to use the old line sets, but you have to document the pressure test on the new system, okay? System evacuation, again, cylinder threads, we've hit that already. Codes and standards, how am I doing on time? 9:01, oh, we're running ahead, okay, very good. We're going to talk a little bit about codes and standards. Codes and standards are going to be the same pretty much nationally, but really it's going to boil down to your local jurisdiction in some places. Not trying to confuse you, I'll walk you through this and show you what it means. They fall under the ASHRAE 15 or 15.2. Codes are very hard to understand right now because they're moving so quickly. It is literally the last part of this, and they're trying to work frantically to get all these codes in the code books, or at least accepted by the states, all right? And everybody be on the same page. If you care to read and you're bored, you can buy a copy of ASHRAE 15. It has to do, so if you're a decision maker or an owner, you probably want to have a copy of that. I own 15.2. It's a long read. I think it cost me $135, but it helps me out. This is commercial refrigerant, A2Ls and other things. And 15.2 is residential A2Ls, okay, primarily, all right, the difference of it, okay? And then you have UL-240 and UL-289, okay, are free to you, all right? And again, UL is the safety of the equipment. The ASHRAE is really the installation. I don't know these by the back of my hand, I'll be honest with you. We actually have people on staff, this is all they do all week. They sit on these code committees and you know, from overseas and everything, watching whatever. It is it's back and forth all the time. So I'll show you what I know for sure, okay? What I know is on the application, again, it's the ASHRAEs. This is gonna be covers ACR systems, refrigerant, commercial refrigeration, okay? ASHRAE Standard 15.2 covers residential AC. Refrigerant classification, ASHRAE Standard 34, that is what the flammable and toxicity is, the standards. When it gets into product design, UL is about the equipment, ASHRAE is about the installation of the equipment. 2-40 covers ACs, heat pumps, and dehumidifiers. 289 covers commercial refrigeration, okay? So it's different in what, depending on what you look at, all right? So how does this work, Don? Well, I'm gonna give her a whirl, okay? So we come out with ASHRAE 2-40 and 15. This is the commercial side of things, all right? So what happens is they come out with the safety standards for that, all right, how it's to be installed, and then it gets implemented in your codes. Like I'm under the IMC, International Mechanical Codes. You have the UM, the IRC, and so on and so forth, depending on where you're at. And different states are under different codes, all right, different codes to follow. They're all fairly similar, but not exact. So it gets to the model codes, the code books in the city or the municipality, wherever you're at, or the state, they go in those books, all right? You have to follow those codes. If you get caught doing something outside of it, you could be in big trouble if something goes awry. If the state doesn't adopt it in the code books, but the international codes are there, the IRC and the UMC, the local municipalities can bypass the state, okay? And the local municipalities like Dayton, Ohio, can adopt it and say, we're gonna put it in our books now, and they can even modify it if they want to. They can make it even harder if they want to. They have that jurisdiction. If anybody's ever worked with dryer vents, I'll just use a simple one. You know, dryer vents in my area, I think it was 40, 60 foot, and every elbow was so many feet, as you know, but on a manufacturer, they'll tell you you can go 100 feet. Well, they don't allow that in your new construction where I'm at. You have to have the pamphlet on the time they do the final and prove to them this is, and then they grace you in basically, but they don't have to. So basically this is all that dotted line says, but this is the chain that happens there from the ASHRAE standards into the model codes, then it goes to a statewide code. Again, they can adopt it and modify it, but if they don't and they're delaying it for whatever reason, either they're just slow or they're still reading it, look, and I'll show you the next slide or two, municipalities can actually do it themselves. This is the latest and greatest I have, okay? This is a moving target every week. If you saw this a year ago, the number would have been probably around 11, maybe less than 10, actually, because I've progressively seen this get farther and further along. Our codes people are pretty tickled. So what this is saying, this is, first of all, this is for air conditioning. We're up to 44 states actually now. Alaska had some issues the other day, so they're backing off for just a second to get some clarification. But as of now, 44 states have approved A2L refrigerants to be installed in some way, shape, or form. If you see the dark green stuff, that means it's fully enabled, okay? If there's a letter C, that means it's actually in the code updates. L means they just adopted the legislation, but it's not in the books yet, okay? S is a special provision. Alabama hasn't put it in their code books yet, but Birmingham has, okay? That's that municipality thing I was talking about. We're up to 40 states, so you can see it's closing in. Kentucky is now green, by the way. They changed recently, so they're not red anymore, okay? This is what commercial refrigeration looks like, a little different, and the numbers now are 39 here, not 40 because of Alaska. So you can see where we're at with this, okay? When it gets into codes, if you care about codes, ASHRAE 15, this is important for people that are involved in codes. Instead of reading the whole code book, you can go to the addendums. For example, addendum C in this code, in ASHRAE 15. Flammables and the points of aggress. Addendum P, refrigerant concentration factors, and so on and forth. Update machinery rooms, ventilation for A2Ls. Do we need to bring air in? And it just, when you click on that, it just talks about that topic and that topic alone. So it's a little easier to find that stuff. Okay. Going to show you some resources we have. Okay. Obviously, you can go to AHRI. You can go to ASHRAE's website. You could even go to Field Piece. I know they're building some stuff up right now really well. You can go to ESCO always. Okay. Known them a long time. Clifton was actually a student of mine years ago. Okay. And we have a Dr. Chuck YouTube channel, Opteon.com. Okay. YouTube channel. Dr. Chuck does these 1 minute, 30-second videos on just fun fact type things that you can digest real easy and go about your way. They come out every month, I think. Pretty easy to dissolve. But this is the most important for me. If you need to call us or want to call us, we have tech support. You can go to Opteon.com also and get a free A2L newsletter if you want to. Go to Opteon.com. All of our literature is free, by the way. It's a lot different for me coming here than it was at Copeland. Like I said, I traveled 36, 40 weeks a year, the same as I do here. It was $395 a day to hear me speak with another mechanical person. Chemours is really big on training. We don't charge anything for our training. We go everywhere and go about. We want to encourage this transition to be very smooth. Okay? That's all I have. Any questions? Yeah.
On the temperature, the pressure relief valve on the tanks, we're talking about the two chemicals separation. Your separation of refrigerants. That's your 32 and your 174 refrigerant, talking about what will be released on that. Both chemicals released or just the one or two?
Yeah, it's going to be the same as a leak. The question was, what about that relief valve? If you were to blow part of the charge, and it stems back to what we talked about on the system, how important or how much science was really put into fractionization. It's just like anything else, like the system itself too. So you're going to have vapor in there, you're going to have liquid in there, and obviously you're going to have saturation in there. So when it goes to burp, if you will, and then shuts off, you don't have to worry about any fractionization. Fractionization really, the perfect world of a fractionation was, first of all, the leak has to be in a coil, like a tank, okay? And then it has to be a very, very slow leak. And then people have to keep putting in charges and stuff like that. But like I said, we don't even get those kind of calls at all. They're just not, back when POE and blends started coming out popular, they just talked about it. But I'm here to tell you too, to contradict myself, is we always charge blended refrigerants upside down in a liquid. It's just the way we do it. And you get a better mixture with liquid than you do vapor. In vapor, you do take a chance of possibly getting pockets here and there, and that's the thought process behind it. So I want to be very clear about that. Good question.
Is anything going to happen if you mix the two refrigerants? Because you guys somebody that.
So the question was, is anything going to happen if you mix the two refrigerants, 454B and 410A? So that's a great question, and I'll try to answer it the best I can. First of all, it's an A2L, so something could happen. Now it's an A1. But the other thing is even though it still has the R32 in it, and it's been bumped up to almost 70 instead of 50%, and I'm a big fundamental person, if you come along, I come along, and I top it off with 454B because that guy from Chemours said they're almost exact on the PT chart. And then someone comes in the following summer or comes in and tops it off. My question to you is, with that 1234YF in there and the removal of 125A, how good is your PT chart? It's kind of like the same people that keep dumping dyes into air conditioners. I tore so many compressors down through the years, and it would look like radiator fluid in a bucket. How good is your PT chart? You just made a Frankenstein refrigerant. You can't tell superheat, you can't tell subcooling. You're not that accurate. You're off for sure. So will somebody try it? Absolutely, I'm sure of it. Do I want somebody? Absolutely not. I hope people do the right thing. But that's where it gets into that liability of you, me, and everybody else once it changes hands from the OEM. Okay, you have to follow the ASHRAE standards or the people in your municipalities.
On the left-handed adapter, that's
Yeah.
only for the tank, correct?
Yes, that is correct. Good question. Great question. Yes. But, however, Tammy's going to bring a tool up here, and I've had other people reach out to me to offer me tools. They're starting to make these little devices with the left hand. Will the OEMs, equipment manufacturers, and hose manufacturers go to left-hand threads? I can't really speak for them. My guess would be about the same as yours. Just it starts at the tank, so we just decided with the red stripe. Actually, we were forced on it, the red stripe, and then the left-hand threads to make sure that that liability was out of the way. So if you knowingly put refrigerant from that tank, like you just talked about, and you see the red stripe, you're knowingly doing something wrong. Okay, so. No, great question. Very, very good question. Is it going to be an issue brazing? Brazing will be the same. You'll still be able to use your compressed fittings also. Anything that you use, whatever brand that is, you can use your compressed fittings. There is no change there. At the end of the day, the refrigerants are still going to be pretty much like for like. And this has been tested for a long time. When I worked at Copeland, I call my shock collar when I was 400 pounds would go off, and my wife would make me walk every hour through the labs. I'd take my ID card, and they're doing testing all the time. The technology we see in the field is like 10 years ahead in the labs. You know what I mean? They're testing these refrigerants. I've seen a lot of these already a long time ago. They're seeing what it does. They're running it through all the tests in cold, hot, are the reed valves, are the scroll sets going to break, safeties and stuff like that. That's a lot of UL goes on up there at Sydney, Ohio. But yeah, pretty much the same stuff on that, the brazing. It's really getting back to the fundamentals. What we did before is, if you're doing the right thing and were before, it's pretty much the same thing. There's nothing, I wish that I could tell you there was something jumping out that was going to be totally different and be aware. But really, it's just, I think documentation is going to be the big one changing here. And California is going to do it first right now, but we're all going to do it, and because the OEMs are putting it in the equipment. So now how is that, no one's ever asked me, how is that going to be policed? It's kind of like when we had our EPA cards, who's going to police me for venting it out? I don't know what that looks like. It's out of my knowledge of realm. So just stay tuned. But they are going to have you documenting that stuff. I saw some other hands.
Early on, they were saying they were going to use like a refillable tank.
Yeah.
Disposable.
Yeah. So that, I'm glad you brought that up. So that, since we have plenty of time, that goes back to that third step in the AIM Act. Part of that was recovery, reclaim. It also in that reclaim area had to do with refillable, reusable tanks like they do in Canada. And basically the thought process on there is if I go to empty that tank, that orange tank, the 404A I was showing earlier, I go to poke a hole in that rupture disc, even though it's empty and our nature is we're starting to lose charge, no pressure, grab another tank of gas, there's still gas in there. This is the thought process behind it. Again, I'm just the messenger. They call that the heel of the tank, all right? What you're supposed to do now, today even, you're supposed to recover that refrigerant that's in that tank. But not everybody does. So you puncture that hole, and ever so slightly, it doesn't seem like a lot to you, me, and everyone else in this room. But if you do that all over the world, that adds up a lot of GWPs. So by having that tank returned back in like propane, they can recover that refrigerant out. They want a QR code to scan it to know where that's going to, where the refrigerant, where wholesaler it was sold at. They want to follow that all the way around and what's coming back, what's being sold. Because right now, if you don't know the ratio, these folks can tell you if they take recovered refrigerant back, the ratio of what's sold to what's coming back in recovery is not very good. It's like 2% or less. It's a very, very small amount. So it's just another way. I hate to use the phrase big brother, but basically they don't know how else to figure this out, basically. So that's the whole idea of the recovery tanks. And they did it in Canada. I think they're being somewhat cautious about it because back at my last years in the field were last 8.5 years, I was a service manager for a very, very large company in Fort Wayne, a lot of big company. So in the cool time of the summer, let's say February, March, when everybody starts to run their sale before it gets hot, it wasn't uncommon for me to buy 4 or 5 skids of R22. And that's just, we knew we were going to use it, right? So when it gets 90 degrees out, price starts getting higher, you're making better money. That's just business. That's what we do, right? So what happened up in Canada is they think like we think. They went and bought a bunch of skids. Well, the people that enforce that, their government or whatever, didn't know how we think. They saw it more as a onesie-twosie, and it really almost bottlenecked their industry up there because they weren't having enough tanks coming back. So I think they're looking at all these things, possibly bumping up some manufacturers to make these tanks, because right now I'm not sure if they have enough manufacturers to actually put these refillable tanks. Will it happen? Yes. And I hate to be the burden of bad news. What's going to happen here is, and I was just on this code call yesterday with the regulators that just came off from the meeting with AHRI and the codes committees. And what it looks like is they're going to reword it and put it in a different section. Basically, it's in a wrong place right now, but they can resubmit it and probably get it passed. When that'll happen, 5 years, 10 years from now, I don't know. But you are right. You're 100% right. And most everyone always asks me about that. I tend not to get too deep into it because there's so much in front of us right now to absorb. I don't want to overwhelm people because it's not here yet. So when it gets here, or if it gets here, there'll be a lot of education about that too, basically. So good. Thank you for asking that question, though.
Is there a limit on how often you can recharge a 22 unit?
Well, I know there's a limit on, a leak. If you knowingly know there's a certain amount of leak that comes out. I don't know those numbers off the top of my head, but yeah, it's in your EPA, a certain amount. But yes, absolutely. I don't know anybody. Yeah. Is that right? I didn't know that. Yeah, I know it has something to do with the loss of charge. You have to knowingly fix something after. I don't know if there's a time frame on it. Yeah, it's the amount of the charge. Yeah, that's what I remember anyways, but that's been a long time ago. But yeah, you got to knowingly fix these, and this is going to be part of this too. Like when you're putting refrigerant back in a system, that's that whole part of that tracking part. What's going out, what's coming in, is it going up there? It's not like somebody's going to show up at your door and arrest you. They're just trying to figure this thing out, right, wrong, or indifferent. There's nothing we can do about it. It's the EPA. So just like the Department of Energy changed, they actually adopted new SEER rules prior to this. It's already been in effect, as the people that work here know. So it's just it's electronic cars. It's just everywhere we look. It's the same thing. It's all for the common same goal, basically, is what it amounts to. Okay, trying to figure out what's worsening it. You know what I mean? What's doing the most of it? All right. Again, I don't get political. I've been married since I was 18, and our house has been divided since I got married. So I won't tell you which one I am. I'll just leave it at that.
Did you say a different recovery cylinder?
Oh yeah. My bad. Yes. So recovery cylinders will also have a red stripe around them. Absolutely. Yeah. Thank you for doing that. Yes. So the tank pressures are going to be 400 like we were before. The same thing, but there will be a red band around them. Yes.
Also, I work for 2 days, so like when we're transporting our 4 to another.
On the box trucks and the semis, from what I understand, yes. That's what I'm being told. Yes. Double check me on the box trucks, but that's what I'm being told. Oh, also, on the other thing too, on tanks, this is hot off the press. There was a lot of scuttlebutt about, hey, rumors get out somehow, and it seems like people want to hear the worst thing, and it's human nature. I'm the same way. Well, what about that? Not the 99% that's going to be easy, but that's going to cause trouble for me. And that's just our nature as humans, right? There was talk of making A2Ls be forced to be upright in the trucks, okay? And if you didn't know, if you look at a box today with A1, it's suggested that it be upright, okay? But how long does refrigerant stay in a box? If you've never read that part of it, all right? And the reason for that is that safety feature, that rupture disc on the tank, depending on where you put that tank on its side, okay? I'm not very good at drawing. Put that tank on the side. If the rupture disc is down here where the liquid is, you take a chance to accidentally relieve that. It gets warm and it blows it out, okay? All right, so they want that upright. They want a vapor barrier between that rupture disc. The same thing's going to hold true for this cylinder. Now, I can tell you they rejected it because it's A2L, and we resubmitted it about a month ago. So it passed all the tests with flying colors, just so you know. So it's been tested and stuff like that, so there should be no worries on that part of it too. And that's brand new. 2 weeks ago, I wasn't even really, 3 weeks ago, I wasn't even supposed to be talking about it.
So with that being said, the refrigerant tank holders that are in 90% of services are diagonal. Hold the tank diagonal.
Exactly.
So with new refrigerants, they're going to have to be standing straight up.
No. There was rumor that was going to be the case. His question was the way that everything's tooled, like the picture I had of the back of a van. I had that in there for that reason. I forgot to touch on it. They're at a 45, if you will, or somewhere thereabouts. There was talk of having to have them vertical, which would be a pain on our trucks, right? We don't need that kind of problem. Well, they went the extra mile and actually tested it because it got rejected back to lay on its side because of the safety thing on there. because it's mildly flammable, and they passed the test. Okay, it just hasn't been published yet. Okay, like I said, a month or so ago, I was told not to even talk about it, but it is. But now I'm seeing it. Other people starting to talk about it. But it's already passed, and it will be submit. It's already been submitted, and you'll be able to lay it on its tank. So great question. I appreciate you going back to a question you didn't understand, because that's real important when you're in the room. Make sure you understand it while you're here.
Real quick, on the recovery,
Yeah.
are those gonna have the pressure valve? Are they gonna be one shot or?
Well, the recovery tanks for the most part are going to stay the same. The only thing that's going to change is the red label on it. Okay, the same way they are now. So they're going to be, whatever your collar says, whatever those pressures are, there's going to be a WC and your tera weight and all that stuff, and what pressure it holds, 400 and some pounds or whatever. That's not going to change at all. The safety device is not going to change on that at all. I have not heard what they're going to do on that yet. And I was with Hudson last week, and she made no mention of left-handed threads. So I'll tell you what, I'll get you an answer today, though. I'm not sure. Do you know Jeff or Tammy by chance? Yeah. I'll have to look. I appreciate you asking those kind of questions, because everywhere I go, then I add another topic to talk about in my presentation. So I'll find out.
So in regards to raising the service, 2 years system runs, it's safe to braze, right?
Yes, you are. Now, when you say safe to braze, it's going to be the same process it was before, and that process is good practices. Good practices before, we were supposed to purge with nitrogen to get any residual refrigerant. So that's still the same, okay? And there's a lot of videos out there. I just don't show them because I don't want to get into trouble. It's not affiliated with Chemours. There's a lot of good videos out there with professors in Australia and different places, and they're actually trying to light A2Ls with a torch right out of the canister. Okay, I'm not trying to play it down, but you'll see once it goes out. There's a lot of videos out there, and but take a look at it, because seeing something and touching something is really registers with us, our industry, right?
That's where you went back for A2L and add to 410A, or was it the 410A, you can't add 410 or A2L
So
refrigerant in 410A
correct.
are compatible.
Correct. You cannot.
But you cannot add, you said in that video, 410A2 with A2L, right?
Yeah. Well, you can't. You don't want to mix refrigerants in it. Yeah. But for sure, on the topic, great question. The A2Ls will not be put in any existing systems as of today, because there are no safety features in there, sensors from the OEMs. That's square one. No A2Ls into the existing systems, okay? And on the hindsight, on the reverse thought of that is, we don't want to mix refrigerants, putting A1s and A2Ls, because then you just made a Frankenstein refrigerant.
And sometimes I'm wondering about the line sets you can't see.
Yeah.
You know?
Well, and that's
And then
why.
you're just blowing it out with
Me too.
nitrogen.
Me too.
I don't know, use flash.
No, me too. You're talking about moving the residual refrigerants.
Yeah.
That's to your own. I'm a big believer in nitrogen. At Copeland, if you go to their 93-11 AE bulletin, they'll show you everything they want in a compressor, and it boils down to the refrigerant and the oil. They don't want you. They want to clean up with suction dryers for so many 24, 48, 72 hours and pull it back out. They don't like, and this is just them, RX11, and simply because the people that own those products didn't pay millions of dollars. It takes millions of dollars to test that stuff, and they either didn't want to or didn't need to, because they sell a lot of it, right? So, but I'm a big believer on nitrogen. That's the way I think, and clean it up with the suction dryer. Anytime you open the system, put a new liquid line filter dryer in. That's just the way it is, a pressure drop, anything like that. But yeah, the cleanup, I think, is nitrogen suction filters. Now in residential, we don't leave them in, right? We clean up the acid and we take them back out. All right. Thank you for asking that question. Yep. But someone asked me that already. He asked if it was left-hand threads. I'm going to look into that for you. Okay. I don't know. Do we have everyone's email in here? So I promise you, we'll send a blast. Oh, by the way, this is my email address. You can haunt me, and as much as you want. Bug me, I don't care. Okay, I will get back with you. Sometimes it's maybe not that day, but I will eventually get a hold of you. Okay, and in the subject line, just put left-hand threads. You were going to get us an answer or whatever you want to talk about. Okay, and if I don't know the answer, like I tell everybody, I've taught only about 8 years. I can find somebody that has the answers, or I'll find it for you. Okay, great questions on that. Appreciate you asking the question. Anyone else? Well, I can't thank you enough for being here today. I know you probably had better things to do, but I appreciate you coming out. Thank you.